All right, ladies and gents, we're back, Unit 10, back and better than ever. This is now recording number 2. The first one got deleted. I don't know what happened, so hopefully this one's even better and even shorter. The first one was like 37 minutes long, so hopefully this one's a little better. All right, graphing sine and cosine functions. Back in Unit, I don't even know when it was. Back in pre-calc, we graphed a whole bunch of different functions that were very similar to each other. We have A's and B's and amplifying and moving up, moving down, translation, stuff like that. And we're going to do the same thing here with sine, cosine. These two actually aren't too bad to do, but we're going to see, I guess, and you're going to be the judge of that. So graphs of sine and cosine look like waves. They literally look like a wave, okay? And they are called what we call sinusoids. Sinusoid, that's an O, or sinusoid. I don't really know the full pronunciation. I'm not a phonetic genius. That's why I teach math. So I think it's a sinusoid. I think that's how it's really pronounced, but I don't know why, but that's what they do. They do what it do. All right, so we're going to use a unit circle from the last unit. Last unit, we're going to use a unit circle. So the cosine of theta is our x value, and then the sine is the y value. And so that's what we're going to use. So if I look at this table, we're going to do cosine first, then we're going to graph it, and then we'll come back to sine and do that after. If I look at cosine of 0 is 1, right? That's the beginning point. Cosine of pi over 2, that goes up, x value is 0. At pi is over here, the x value is -1. 3 pi over 2, I go down here, the x value is 0. And then I went all the way around there, and I got 2 pi, and I got 1. So you can see that it starts at 1, it's going to end at 1, and then in the middle here, it's going to kind of go up and down. All right, so it's going to kind of go up and down in the middle there. So let's use that knowledge to then graph it. So let's use what we just did to graph it now. And we know that the cosine of 0 is 1. That's what it said. It also said that the cosine of 2 pi is 1. Now, this is what we call, we're going to get into this more in a little bit with definitions, but because this is a maximum, right, this is the highest point on this graph, so the cosine is going to start at a maximum. Now, it could start at a minimum. We'll get to that as well. But right now, your knowledge, it starts at a maximum. Okay? It also then comes back to a maximum at 2 pi. So we're going to call that a period. Okay? A period is 2 pi. All right? We'll get into the definition exactly, but the period is just when the cycle repeats. So when it starts to repeat itself. Remember, these are sine waves. These exist from negative infinity all the way to positive infinity. So they don't just stop on our graph. They keep on going. And then in the middle of our period, from 0 to 2 pi, halfway between, we have a minimum. Okay, so this is a maximum. Halfway between, we have a minimum. Remember the cosine value of pi? Guess what that one was? That was -1. Okay? And then halfway in between those, we're going to have zeros. Remember, the cosine of pi over 2 was 0, and the cosine of 3 pi over 2 was 0. So then you can see that your graph is going to be awesome like this. And then if I went to negative pi over 2 here, I would get 0, so this would come back down. And then if I went over here, that would come back down as well. So you can see that's a generic wave. Do not draw just a line. Don't be like, I want to draw a line. I'm going to draw a line because you said it's okay. I'm not saying that. Don't do it. All right, these need to be rounded, just kind of like parabolas, like you need to have some sort of rounding at mins or maxes. All right, let's go graph sine. Or not graph it, let's go to our table. So sine is the y values. All right, we just talked about that. So the sine of 0 is 0. Fantastic. Sine of pi over 2 is, the y value is 1. Great. Sine of pi is 0. Great. Sine of 3 pi over 2 is now -1. And then 2 pi comes all the way back around. We hit 0 again. So you can see we hit 0 3 times. So in the period now is from here to here, right? That was just like here. We had the cycle repeats itself every 2 pi in a generic, right? In a parent function. So in the middle of our period, we hit another 0. And then in the middle of that values, we hit a max and a min. We'll get to that down in the graph right now. So at the sine, what happens is it starts at the origin. The origin is 0, 0. So that's where our parent function is going to start. Our period, which is the cycle repeating itself, is 2 pi. So that's also 0. And then in the middle of that period, it also hits a pi. And so then in the middle of that, it either hits a min or a max. So think about this, okay? At the beginning point, this graph is always going to go from below to above. So it's going to literally, graph is going to go like this, okay? Then at the end of the period, the cycle here, it's going to do the same thing. In the middle, it's going to do the opposite. So it's going to, instead of going down to up, it's going to be going from up to down, okay? So that means that the graph is going to look like this. But now I got to find the value. So the sine of pi over 2 was 1, and then the sine of 3 pi over 2 was negative 1. So there we go. That's the sine graph, okay? And then if I wanted to go negative pi over 2, that would be down here. So technically this is going to be there. And then if I wanted to go to the other one, that would be up here. So that would be kind of like that. All right. So that's what a sine graph and a cosine graph is doing. So this one starts at the origin. Remember, the cosine starts at a maximum. At maximum. Now that depends on some other things, but right now, parent function starts at a maximum. All right, standard equation. These are standard. A is going to mean something, and B is going to mean something, just like we had in some other equations that we were graphing, like square roots and parabolas and cubics and absolute values and all of the other awesome stuff that we did in pre-calculus. And now I'm going to use the A and the B value for some of these. The amplitude is the absolute value of A. Okay, the absolute value of A. So now you have this crazy mathematical definition. I'm going to read it to you in a 16th century Scottish accent. Maybe British. I don't even know. The maximum displacement. I'm just kidding. That's not even an accent. It's not even English. But I don't even know how to do English. So I don't even know. The maximum displacement or distance moved by a point on a vibrating body or wave measured from its equilibrium position. That literally just sounds like gibberish. If you don't know what math is, you're like, what? I don't know what this means. The displacement is just up or down. Okay, how far it goes up or how far it goes down from its equilibrium position. The equilibrium position is, for the most part, it's the x-axis. Okay, the equilibrium position is just the middle of the graph. Middle of graph. That's probably the easiest way you could understand it. So now, if I have a graph here, I'm going to say cosine. Okay, remember the cosine is at a maximum, and then it's at a minimum, and then it's back at a maximum. So it goes down and then back up. Well, the x-axis there is the middle of the graph. Half of it is above, half of it is below. That's the middle. Okay, we'll get into some way where that's shifted, but I'll explain that when we get to it. So middle of the graph, that's what amplitude means, absolute value there. Period is 2 pi over b. So I take the b value, I take 2 pi divided by whatever the value is, that gives me the period. That just tells me how fast or slow the graph is changing to complete one cycle. So for instance, the parent function graph, it was very slow. It was like this, right? It was very methodical and very slow. But what if I had the same graph just with our period being like pi? So this is 0 to 2 pi. Okay, this is 2 pi. What if I was 0 to pi and 2 pi was over here? Okay, so now it would be really crazy. It would be like, woo! So you get more hips and valleys, hills and valleys, Hill Valley with Marty McFly from Back to the Future. Great Scott! Okay, hopefully you guys seen that movie before. So you get more if you have a shorter period. So the period in this was pi. What if you had a period that was like 4 pi? Okay, so this was now 0, and 4 pi is, say, way out here. So it would be really slow. All right, so you can see the difference. That's what a period does. Frequency is just the reverse, the reciprocal of the period, so it's really b over 2 pi. All right, and that's just, this is more actually for real life, but this is really what we call the rate of change. When we talk about like earthquakes and we talk about sound waves and light waves and what else? Microwaves or waves from the ocean or tsunamis, stuff like that. Anything that has a methodical wave to it, like it's a recurring kind of thing, like up and down and up and down, like an earthquake. Those are pretty awesome. That's where we talk about frequency and the rate of change, like how many things per second or per minute or whatever's happening there. All right, let's keep going. I think we're making pretty good time. We're like 11 minutes and 47 seconds. I think we're like, I'm thinking I'm going quicker this one. Hopefully you guys understand what's going on. If you don't, just ask. But man, I feel like I'm doing great. All right, so we got to start graphing these functions. We're going to use the amplitude, the period, and the frequency that we just talked about. This is not as difficult as you might think. We can do this without a calculator. Yes, I know we can. Imagine what these old people were doing back in, like, I don't know, 1980, and then, in the previous 15,000 years or whatever. No calculators were doing this stuff. Who would have thought? Who would have thunk? So the amplitude is just the absolute value of the A value, right? So it's the absolute value of 3, which is just 3. We'll get to that in a little bit. The period is, I'm going to take the 2 pi here. I'm going to divide it by the B value, and I get pi. That means that this graph is going to repeat itself every pi value. The frequency is just the reciprocal of that, so that's just 1 over pi. That's pretty easy. We don't need the frequency to graph. We don't need it. It's just there to help us understand what's actually going on. We'll use it more in the application process and more real-world applicable stuff. So the amplitude is 3 from the equilibrium point. Well, the equilibrium point in this graph, I'm going to tell you right now, since there's nothing over there, it's not like a plus c value, then the amplitude is going to be the x. The equilibrium is going to be the x-axis. So the x-axis is our equilibrium. Great. Now, let's graph this. Where does the sign start with? The sign starts with 0, 0. It always starts there with the parent function. Then we either moved it up or down, left or right. But because there's nothing here to move it up or down with, we're going to stay right there. Then the period is now pi. So at pi, it's going to also cross. That's where it comes back. Then at 2 pi, because that's another pi. Then at negative pi and negative 2 pi. Okay? Now, if we remembered what I said from before, when we graphed it way up there in the parent function, was that these here are going to go like this. They're going to be pointed in this direction. Okay? Pointed in this direction. Then, halfway between those two, it's going to be pointed in the opposite direction. Okay? So that's how we graph those. So we can see that now we have mins and maxes in between our stuff. This amplitude is now what happens to it. So in between those, which is right here, the amplitude, I got to be 3 away from the equilibrium. So 1, 2, 3, dot. 1, 2, 3 down here. Because I'm coming down and going up, that's why it's below here. So this is going to be up, this is going to be down, this is going to be down here, up, down, and then up again. So now we can see that if I'm going to go up and down and up and down and up and down and up and down and up, and it does keep going, but that's not a big deal. So that's what it looks like. The period amplifier, it's maximizing the cyclic value of our graph because now we have more hills and valleys. Okay. Number 2 here, cosine. The amplitude is the absolute value of the A, which is 2. The period is 2 pi divided by the B value, which a fraction, right? Divided by fraction. Remember, I multiply by the reciprocal, so that gives me 4 pi. And the frequency is just 1 over 4 pi. Again, frequency doesn't help graphing, but it's okay to keep doing it. So what happens? Remember, our cosine starts at a maximum. But this is negative, so now it's going to be flipped. Okay, so now it's going to be flipped. So because the amplitude is 2, it's supposed to start at 1, but now it's going to start at 2 because the equilibrium point is the x-axis and it's 2 away from the x-axis. Okay, you got to think about that. Just because our amplitude is positive here, because that's the absolute value, we got to come back and look at this. If this is negative, then the graph is flipped. Graph is flipped from, oh, that's terrible. From right, we've done that before. Okay, that was negative, we flip it upside down. So our period is 4 pi. So that means, actually, we can't even graph this, right? Because 4 pi is way over here, and actually off the video there, right? So what do? Well, we can kind of use our brain. I know sometimes it's hard for some of us, but we can think about what happens in our brain. So if my 4 pi is going to be over here at another minimum, that means halfway between at 2 pi is a maximum. Okay? So that means over here, again, 4 pi is way over here, but 2 pi is going to be a maximum because it has to be in the middle. If one's a min, then the other one has to be a max. Now, halfway between those, that's where our zeros are. And then there we go. We got a graph. Boom. Boom. And then there we go. All right, you can see that one is now slow, like somebody sat on it, okay, like me. All right, I got tired and I needed to sit down, so I sat on the graph and kind of squished it. I do that to a lot of things. All right, good. Let's go. All right, number 3 here. So now we have this +1. In our traditional graph, okay, without that +1 there, or in this case the +3, our equilibrium point is going to be our x-axis, okay? But all that one does is just take and move it up 1. That's it. So the equilibrium point is now at y equals 1, okay? So this is a sine graph, so our amplitude is going to be the absolute value of 2, which is 2. Period is going to be 2 pi over 1/2, which we already did is really 4 pi, multiplied by the reciprocal, and this is going to be 1 over 4 pi. Fantastic. So what happens? Well, the sine starts at the origin, but because I shifted the origin up, it's now right there. Our period is 4 pi, so that's going to be over here somewhere, right? But remember we said was, if it's at 4 pi, it's going to start repeating. That means halfway between, it's also going to do the same thing. With sine, that's what happens. Okay? That's what happens. So then over here, it's also going to repeat. Because this isn't a negative 2, it's going to do the same thing. So at our 0, 0 origin, it's going to do that. And this is the halfway point of 2 pi, so that has to be the graph looking like that. Well, where's halfway between 0 and 2 pi? Well, that's now pi, right? Pi. So our amplitude is now 2, so I got to go 2 up from that line. So 2 up, and in this case, it's 2 down, which is right there, 2 down from that line. So I can see that our graph is going to look like that and going to look like that. All right, so that's a slower graph, again, just like the cosine one from before. Looks like I sat on it, I got lazy, and I got tired. I walked like 10 feet, and I was like, I need to take a break. All right, I want you guys to take a break. Pause the video, try number 4 yourself. Take enough time there if you need to hit play before hit play, but pause real quick and do it. All right, so I grabbed some things here real quick. I moved the equilibrium point, the equilibrium value up 3 because that's what this 3 tells us. The amplitude is 4. Absolute value of negative 4 is 4. The period is 2 pi over 2, which is pi, and then the frequency is plus 1 over pi. So here we go. The cosine is, so it should be 1 away from the equilibrium point in the positive direction. But because this is at negative 4 and the amplitude is 4, I'm now going 4 away in the negative direction because of the negative. So 1, 2, 3, 4. So this is where the cosine graph starts. That is your minimum. It repeats itself at pi. So where's pi? Right here. So it's going to repeat itself there. It's going to repeat itself there. And there. And at there. Okay? These are minimums. So where is halfway between those two values? That's going to be a maximum. Halfway between is negative pi over 2 and pi over 2 and so on. So that's going to be 4 away in the opposite direction. 1, 2, 3, 4 up here. 4 right there, and right there. Then we just graph them. Now you can be like, well, halfway between those is going to be a 0. Yeah, and that's true too. You can graph that. That's not that big of a deal, but you could graph that. So it's going to be up and down, and then 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 it repeats. So again, this is because the period is smaller than 2 pi. It's going to repeat itself a lot faster. All right, this is, I don't know, I can't even reference this because I can't sit on this. I don't know what's going on. Anyway, so it's a lot faster. Let's get on to some other examples here. All right, I kind of cut off the thing there. Let me see if I can get back up there. Yeah, buddy. I want to write an equation using sine. So remember, sine is f of theta is equal to a sine of b theta. Okay, and then there's going to be something over here, maybe a plus c or something like that, which that's where the vertical shift is going to happen. So amplitude, I need to plug in the values, right? So f of theta is equal to the amplitude, which is 5, so that's 5, of sine of something theta. It's going to go down 4, so we know that this is a minus 4. That's pretty easy. Those two are pretty easy. The period is what's going to get you. How do I do that? Well, remember the formula for period was 2 pi over b equals 4 pi. 2 pi over b is just a formula. 4 pi is what this is. This is the actual period. So this is the formula. This is the actual. And I want to solve for b. Pretty simple. I'm going to multiply both sides by b. So I get 2 pi equals 4 pi b. Divide by 4 pi. And pi's cancel. These are going to cancel over here. So b is equal to 1/2. And so then this is going to be a half. And there is your equation right there. Okay? Number 6. Again, amplitude is pretty easy. So f of theta is equal to 3 sine of something theta. And then up 1 means plus 1. Period is 2/3. So I'm going to take the formula. 2 pi over b equals 2/3. These are fractions now, so I'm going to multiply crossways. So I get 6 pi equals 2b, divide, so I get b equals 3 pi. So that is going to go, that is going to go in the parentheses, the parenthesis. So 3 pi theta. There is your equation. That was not that difficult, actually. So just take some time, but it's not that bad. Last one here, and I think we are like 12 minutes ahead of this video already, so your boy is throwing it down. All right, here we go. Write a cosine function of this graph. Okay, remember cosine is f of theta is equal to a cosine of b theta, and then maybe a plus c if we need it. So let's see here. First thing I got to do is I got to find the equilibrium. Equilibrium, which is the halfway, the middle, right? The middle. I love that show. That's so good. The middle. I think it's supposed to be like portrayed in Indiana, right? Is that really how people in Indiana are and act? I don't know. I don't think so, but maybe. Middle. Where is the middle? The middle is at -1. All right, you can see that that's halfway between the highest and the lowest point. That's where those values are. So that means we shifted the graph down 1. So this is really a -1. Okay. The amplitude is from the middle to the highest or lowest point. So I went 3 difference there. There's a 3 difference there. So the amplitude is a 3. So f of theta is equal to 3 cosine of something theta minus 1. Now you might ask, why is that not a positive 3 or a negative? Why is it not negative? Well, because remember the cosine starts at a maximum. Because at 0 it's at a maximum up here, that's why it's positive. If it started down here as like a minimum, then it'd be negative. All right, so pretty simple there. So how do I find the b? Well, this is where it starts. Where does it now repeat itself? Well, it repeats itself at pi. So from 0 to pi is the period. So the pi is period, or the period is pi. There you go. That makes sense. So I'm now going to find the b value by saying, okay, well, it's 2 pi over b equals to pi. If you remember the shortcut, I can just flip these two because that's not a fraction. I can just flip them. So it's 2 pi over pi equals b. b is equal to 2 because those cancel. So that is what it is. It do what it do. All right. So there you go. Hopefully you saw the sign and it opened up your eyes. And this video is probably 10 minutes shorter than my original. So you're probably like thanking me right now. But all right, have fun, ask questions, and deuces.